This is section 11A. We're going over sets of numbers, and I want you to be able to classify and order real numbers. Some of your vocabulary, rational numbers, irrational numbers. We are classifying here, so the first thing I want you to do is circle real numbers. Now, all of the numbers that we're going to deal with until we get to chapter 5 are in the real number system. So we can classify them, and when we give them names, we're able to tell what group of numbers go with our group of numbers. Trying to adjust my camera here. Okay, so the real numbers are broken into two different categories. We have irrational numbers, and I'll give you a couple of examples, and then we'll also define it down a little bit below. And then you have rational numbers. So every number that we talk about until we get to the complex number system is going to be in the real number system. And then you have to choose if it is rational, or irrational. The most common irrational number is pi. You can take the square root of prime numbers. So example, square root of 3, square root of 5, and so on. There is another irrational number that we'll use when we get to chapter 7, and it's represented by E, and it is 2.718, and then it just goes on with no repeating pattern. We can also have an irrational number like 4.9832 ... We can't see a pattern here, so we can't predict what comes next. That's why it's called irrational. Now, rational numbers, you can see the word right here, ratio, which means we can write the number as a fraction. So 1/3 would be a rational number. Now, if I change that to a decimal, and I did 0.333, it would go on forever. But the difference between these two decimals is I can predict what the next digit in this number will be. We know it's going to be 3. The 3 will go on forever. So this is rational. Some people think that the difference between irrational and rational is that an irrational number goes on forever. It does, but it does not have a repeating pattern. Okay, I'm trying to fix my camera here again. It's just not staying put. All right, now we are going to build the number system on the rational side, and we're going to start with the natural numbers. These are also called your counting numbers. They're the numbers that you naturally count with. So when you first started to learn how to count, you started with 1. You didn't start with 0. So we go 1, 2, 3, and so on. Those are your natural numbers. Then we're going to add whole numbers, which are going to include the natural numbers, but also 0. So we add a 0, and then we go back and write the natural numbers. 1, 2, 3. The next set would be the integers. And those are the whole numbers, and then we're going to add their opposites. So we're going to, can you keep going to the left, and then we'll add -2, -1, 0, 1, 2, and keep on going. Okay, now we're going to use these definitions, this diagram, to write the definitions of rational numbers and irrational numbers. So a rational number, and again I'm going to circle this ratio, which means you can write it as a fraction, can be expressed as a quotient. And I'm going to circle this Q because on your worksheet for today, the letter that you're going to use to represent rational numbers is Q. And that's because the numbers can be expressed as a quotient, or the ratio of two integers where the denominator is not 0. The decimal either terminates, which means that it stops, like if you take 1/5 and you change it to a decimal, it's 0.2, or it repeats. So example, 4/3 would be 1.3 with that bar over it, which is 1.3 ... Okay, now, irrational numbers cannot be expressed as a quotient, so they cannot be written as a fraction. Their decimal forms do not terminate or repeat. And here are some examples. You'll always want to take the number and change it to a decimal so you can put it, it makes it easier to order the number and also to look at the pattern to see if there is a pattern. Okay, so when you are classifying real numbers, let's go down to this table here. Because I say that it's a real number, we need to check or put an X in the box for all the real numbers. So on your test or on your quiz, you should always have all of the real numbers checked. The next thing that I'd like you to do is kind of put a squiggly line around these two columns. The reason why I'm having you do that is I just told you that all the numbers should have real checked. In addition to that, they have to either be rational or irrational. They have to be one or the other. So any number that you classify will always have two classifications for it. Okay, we are going to change this to 2, the number 2. Now we're going to go across here. We need to decide if it's rational or irrational. And if I go back up to my diagram, 2 falls in the natural number, so that means it's on the rational side. Now, if you say that a number is rational, you also have to decide if it's natural, whole, or integers. If you say that it's irrational, there are no other subclassifications there, so you'll be done. So let's go back down to our table. Since it's 2, it's on the rational side. Now I have to decide, is that a number that I naturally count with? And it is, so we'll put an X there. Now we have to check the other classifications. It's natural. If it's natural, here are your natural numbers. They're included in the whole numbers. They're also included in the integers. So we'll check whole number and integers. Now the next one that we have is a negative number, and it's also a decimal. What I would like you to do, we're going to go down to this chart here. I probably should have had you do this earlier. We're going to say choose one, which means you have to have one of those. Now I'm going to have you put like a brace, upside down brace here, and I'm going to write no decimals or fractions, which means if a number has a decimal or fraction, you're going to skip those 3 columns. So this number terminates or it stops, so we can predict what comes next. So it's not irrational like an irrational person that's all over the place. It is rational. We can tell what every digit in that number is. So we're going to check rational for that one. And because it has a decimal, we're going to skip these 3 here. Now we're going to find out what the square root of 17 is, and that is approximately, I'll just tell you what it is, right around 4.1231, and then it keeps on going. There's no pattern that repeats, so that means that it's going to be irrational. We have no idea what comes next. Irrational. All right, now because it has a decimal, that means we're going to skip these 3 columns. Okay, the next one is 25 times 0, which is 0. Now, that's not a number, well, let's go rational and irrational first. This number stops, so it's going to be rational. And this is not a number that we naturally count with, so we're going to skip over natural. However, a whole number is a natural number plus 0, so it is a whole number. And it is also an integer because integers are whole numbers with their opposites. So we're going to check, going to go past natural, we don't count with it. It is whole and it is an integer. Now pi, that's the most common irrational number. We put that in our table up above. So we're going to check irrational, whoops, wrong. Nope, that's the right line. Okay, irrational. And remember, if it's irrational, there are no other subclassifications for it. 2/3 we can write as 0.66 repeating. So because if I ask you to find the 10th digit, you would know that it's a 6. So for that reason, we're going to say that it is rational. We can predict what the next number is. However, because it's a decimal, we're going to skip over these three classifications. All right, last one we want to do is negative 51, and it stops, so we know that it's going to be a rational number. It doesn't have any decimals or fractions, so we need to check these categories here. Now, if you look, you do not, when you count, you don't use negative 51. So we're going to skip over that one. If we look at the whole numbers are your counting numbers in zero, so they do not include any negative numbers. However, the integers do. So this one, we're going to go over here and we're going to check integers. All right, we are going to order numbers from least to greatest on the other side. And I didn't print out the page, so I'll just write the numbers here. Your number is 0.6. That's repeating. Well, actually, I'm just going to have you change all of those to decimals. Anyone that are not in decimal form, put them in decimal form and write them in order from least to greatest. And then finish up the rest of that side.